Let's look at the rules for sine, cosine and tangent when trying to solve trigonometric equations. Starting with y equals sine of x, let's say we have a solution at 30 degrees, which we'll mark on the axes, and we'll look at this solution on the graph at this point. If we wanted to work out at what angles these solutions repeat, we could just draw a horizontal line across the graph in the following way. So we can see that on this horizontal line, this crosses the curve at 1, 2, 3, 4, 5 points between minus 450 degrees and 450 degrees. Now there are general relationships between these solutions that we can establish using this example. So the first thing we'll look at is the solution on the right hand side of 30 degrees. And due to the symmetry of the curve between 0 and 180 degrees, this first solution to the right occurs at 150 degrees. And so the relationship between 30 degrees and 150 degrees is that if we take our first value, which is 30 degrees here, and then we do 180 minus 30 degrees, we then get 150 degrees. Which we can see both produces the same solution. And so generally we can say that when we have sine of an angle, say x, then this is equal to sine of 180 degrees minus x. Now if we look at the next solution on the graph, this occurs at just above 360 degrees. And the way we get the angle for this solution is we take our first value, which is 30, and we add it on to 360. So this gives us 390 degrees. And so we can see at both 30 and 390 degrees, we get the same solution. So again, if we generalize this, we can say that if we have sine of an angle, say x, then this is equal to sine of that same angle x plus 360 degrees. This also occurs if we subtract 360 degrees due to the following reason. So if we look at 30 degrees, if we take away 360 from this, then 30 take away 360 is minus 330. And if we look along the x-axis, minus 330 is at this point here. Now going up to the curve, we can see that this produces another solution, which is exactly the same as the one at 30 degrees. So therefore, sine of an angle, say x, equals to sine of that same angle x plus or minus 360 degrees. Now this solution here can be obtained if we look at 150 degrees and we take away 360. So 150 take away 360 gives us minus 210. And so looking on the x-axis, minus 210 is at this point, and we can see going up to the curve, this produces our solution, which is exactly the same as the other four solutions here. Let's move on to y equals cos of x. So again, we'll start by considering 30 degrees. And so 30 degrees is at this point here. And now we're going to consider where the other solutions are on this graph by drawing a horizontal line. And so we can see from 450 degrees to minus 450 degrees, there are 6 angles that produce the exact same solution. And so let's establish some rules for y equals cos of x. Now, due to the symmetry of the graph, our first solution is at 30 degrees, and our next solution here would be at 330 degrees. The reason for this is because between 0 and 30 degrees, we add 30, and if we now start at 360 degrees, if we take away 30, we end up at our same solution here at 330 degrees. And so the general rule for cosine is that cos of x is equal to cos of 360 degrees minus x. We can now obtain the next solution by considering 30 degrees and adding 360 degrees to that. The 30 plus 360 gives us 390 degrees. Likewise, if we were to take away 360 degrees from 30, then 30 take away 360 is minus 330. Which is at this point here. So we can see that both of these angles produce the same solution. So again, generalizing, we have that cos of x equals to cos of x plus or minus 360 degrees. Another rule we can establish is that due to the symmetry of the graph about the y-axis, each of these angles that we have, if we take the negative of them, we also end up with exactly the same solution. So for instance, 30 degrees, if we take the negative of that, we get minus 30 degrees, which is at this point, and we can see from the graph that we get the same solution. Likewise, 330 degrees, if we take the negative of that, we get minus 330, which gives us the same solution. And so this last solution here would be the negative of 390 degrees, which is minus 390 degrees. And so generalizing this, we have that cos of an angle, say x, equals to cos of that same angle, but the negative of it. Another rule to consider is the period of each of these graphs. So the period of a graph is the total length or the total angle required to complete one full cycle of the graph. So if we think about the sine graph, so from 0 to 360, we've gone up once to 1 and we've gone down once to minus 1. After 360 degrees, we see that the graph repeats itself now. So going up to 1 at 450 degrees, we've already done that between 0 and 90. And so the period of the sine graph is equal to 360 degrees. So for the cosine graph, if we start at when x equals 0, we have our graph at 1. This then goes down at 90 degrees, goes down to minus 1 at 108 degrees, comes back up at 270 degrees, and then goes back up to 1 where we started off at 360 degrees. And so the period of the cosine graph is again the same as the sine graph, which is 360 degrees. The final graph is y equals tan of x, and so if we think about where solutions repeat here, again let's use 30 degrees, which is say at this point. Then going up to the graph, we can see we end up on the curve. Now to work out where the other solutions occur, we again draw a horizontal line. And so we can see between 450 degrees and minus 450 degrees, we have 5 solutions that are exactly the same. Now to determine where these solutions occur, if we start at 30 degrees and we add on 180 degrees to this, we get 30 plus 180, which is 210. And we can see that this is where the next solution is. Likewise, if I was to add 180 to 210, I would get 390, and 390 degrees is where the next solution occurs. If we then subtract 180 degrees from 30, we end up with negative 150 degrees, which we can see gives us the next solution. And then subtracting 180 degrees from this, we end up with negative 330 degrees, which gives us the next solution. And so we can generalize this for the tan graph as tan of an angle, say x, is equal to tan of that same angle x plus or minus 180 degrees. And this is the only rule for the tan graph. Finally, if we think about the period of the tan graph, then remember that the period is the total length or the total angle to complete one full cycle. And so what we can do is we can consider one of these curves and see how many degrees do we need to complete that cycle. So let's think about from 90 degrees here. This curve on the right hand side goes up at 180 and then up to this asymptote at 270. Then we can see that the curve repeats itself after 270 degrees. So between 90 and 270 degrees, we have one full cycle. So the period must be the angle in between. So 270 take away 90 gives us 180 degrees. And so the period of the tan graph is 180 degrees.